Hello everybody, how are you doing? Today we'll go into the topic, into the new topic, and it is about system of linear equations. And we will know what is it, the concept of the determinant of the matrix. How does this concept, on which basis it rise up? Let's start our work. System of linear equations. I dropped one letter here, equations. Okay. The very basic view of the system of linear equation is the following one. A11 x1 plus A12 x2 plus, I skip all these terms, A1n xn equal, I do not like B1, A21 x1 plus A22 x2 plus etc. A2n xn equal B2. So we have at least n number of, at most I mean at least n1 number of equations, a n2 x2 and n xn equal bn. So we have n number equations and x n number of unknown variables. Here a, ig, some factors or numbers, and x, I do not like 1, x2, xn are unknown variables. So to solve the system of linear equations means to find all numbers, these unknown variables. If you find all of them, it means that you solve the given linear equations. I want to highlight them. This is unknown variables to know, and here some numbers. Let's consider some examples. You know from school, 2x equal 1. You can say that this is the system of equations of one equation and one variable. System of one equation, and here you have just one unknown variable. So you can consider this the system, the one equation as a system of one equation. For example, 2x minus 3y equal 2, 5x plus y equal, for example, 7. So here you have a system of two variables, two equations, and two unknown variables. Okay. The matrix form concept. Matrix form. Of the system of linear equations. So I use here a system of linear equations, abbreviation acronym to make easy our lecture. Look, if you remember the written form, I make this. I write down this one more time here, plus here 1 n xn equal b1. We have all of them. I skip all of them. 1 n x1, 2 n n1 x1 and 2 x2 plus n a n3 x3 equal b n. Look, if I denote A as a matrix of the coefficients of these factors or coefficients of the equations, and here I skip all. And x as a column matrix, x1, x2, x3, xn, and b I put here comma b equal b1, b2, bn. I can write down this system of equations as in the matrix form. A times x equal b. You can notice that this notation is easier than the previous one. And let's make an example. How does it work? Example 1. So we have here, for example, system of two equations, 2x1 plus 3x2 equal 1, for example, minus x1 minus x2 equal 4, for example, 4. So A matrix, I can gather all elements here according to this notation, and I have 2, 3, minus 1, minus 1. Matrix X equal x1, x2. Take into account that these elements keep their sign according to the given equation. If you have here a minus, it doesn't mean that this a to 1 is 1 just. It is minus 1. And b here equal 1, 4. Okay, next one step. Example 2. I have a matrix. I have a given equation, system of equations, the following one. Minus x1, for example, plus 2x2 minus 3x3 equal 0. X2 minus 5x3 equal 2, for example, and we have x1 plus x3 plus x2, for example, equal 10. Let's transform this thing into matrix form. So A matrix. Let's gather at a matrix A. A11 here, minus 1. Next one, 2, minus 3. Here you can see that there is no x1, but it doesn't matter that there is no element here. It means that this one element is what? How do you think? What is it? Yeah. Somebody who knows that it is, or who guess that it is 0, it's true. It's 0. Because 0 times x1 gives nothing. 1 minus 5. And with the last one, we have 1 and 1 and 0 for x3. So it is matrix A, matrix B equal x1, x2, x3, and matrix 6. I'm sorry, this is matrix 6, and matrix B equal 0 to 10. Okay. By the way, if you multiply A times X, you have minus 1, 2, minus 3, 0, 1, minus 5, 1, 1, 0. Here we have x1, x2, x3. This matrix is 3 by 3. This matrix is 3 by 1. The result is matrix 3. We have to take the at the very left and very right numbers, 3 by 1, and you have minus 1 times x, 1, 2 times x2, plus 2 times x2, plus minus 3 times x3. Next one element, O times x1, 1 times x2, minus 5 times x3, and the last one, 1 times x1, plus 1 times x2, plus 0 times x3. And all these things in our matrix form equal 0 to 10. You can notice that we have really exactly the same equality as the given one equations, system of equations.